Hey guys, what's up? This video is a part of the 50 Rust project playlist series on my channel. In case you don't know about this playlist, go to my channel playlist and there's a 50 Rust project playlist, and we build really awesome projects in this playlist series. All right, all of that obviously in Rust. Now today in this video we're building a project using the Chat-GPT API with Rust. And I built a similar video for Golang, and that was really popular and everybody's loving it. So I thought, why not build something similar with Rust? But then there's a small twist here. It's a CRI tool, but we're not just interfacing with ChatGPT. We have a small change wherein whatever you write here, ChatGPT is going to convert that into a SQL query for you. So let's say you say create a table with names, with columns, name, age and gender. If you pass it these three things, it will think for a while and it will return to you an SQL query. So whatever statement you write is going to create an SQL query from that statement, right? So let's say select all documents from employee table. So it's select star from employees. And this is perfect, right? So if in case you don't want to build your own SQL queries, this is the place to be. In case you want to learn SQL, this is the tool you can use. So this is a small tool. You can think of it as a small tool which you can ship, which you can package and ship and even sell. So people can come and learn SQL on your tool. It could be an edtech company, right? So it's not even like 80 lines of code, and this is the kind of output you get. So truly revolutionary, right? ChatGPT, and then you can leverage Rust to do this kind of stuff. So I hope this excites you as much as you know it's exciting me, because I can see a lot of possibilities from stuff like this. By the way, if you have not subscribed, you should. And obviously this code is already there on GitHub, on my GitHub. So I'm Akhil Sharma 90 on GitHub. All of the projects we've built till now in Rust, and everything that we've built in Golang, all of that is there on my GitHub channel. You need to follow me there as well, so that you come to know whenever new projects come out there. Also, feel free to share this kind of stuff with your friends, right? Because the more people know about this kind of content that I put out, the better, because the world at large benefits from this. You don't find this kind of stuff online easily. Anyhow, now let's start building our project from scratch. All right, so here we'll say cargo new and let's say Rust ChatGPT YT for YouTube, and I'll cd into it. I'll say Rust ChatGPT YT ls to see it has created a cargo.toml file and src folder with the main .rs file, and I'll open this up in my code editor. Okay. Now I'll put in a few comments just to indicate what all we need to do. We'll need some structs to work with the API response. Okay, because structs are sorry, my phone will keep buzzing in between. Please don't mind that. I've ordered some food. And I have to coordinate with the delivery guy. Anyhow, so we need some structs to work with the API response, because structs are your own custom data types that you create in Rust and Golang, right? In case you're new to this channel and you don't know about structs, so you need to have some structs that will help you to work, structurize the data that you get from the API, because you don't need all the fields, you need only some of the fields. That's what you'll define in the struct. Okay, so usually you get a response, but you also get some choices. So a struct for the choices is again something that you'll need. All right, so you'll need, for choices, you'll need a response, and you'll need a struct for the request you will make to the API. And here, instead of say some structs, let's say a struct. Okay, so we need 3 structs. In case you've seen my Golang ChatGPT video, you'll know that we get back choices, and we want to print only some of the choices that we get back from the ChatGPT API. And then I'll be using Tokyo to create my async main function. because I need to make an async request to the Chat-GPT with the Chat-GPT client, and I'll have to await for it to bring back the response. I'll load my environment variables. I'll have a .env file also here, where I'll put in my OpenAI token, right? Now, Chat-GPT API is not free. You sometimes get credits, so try to get credits, or otherwise just put it in your cart. It's very cheap. They charge you per token. Token basically means this token is obviously the API key, but the Chat-GPT API charges you per token. Token basically means each single word that it generates for you. It charges you per word. So just be mindful about that. But it's also very cheap, so you don't have to worry. You can also set limits, like whatever you're comfortable with. Like it shouldn't go above $5 or $10, whatever you want to set the limit to. You can also do that. So it's going to load the environment variables. It's going to create a HTTP. So we want to create a HTTP connector, and we'll use something called the Hyper library for that. And we create a client, obviously. The client, so we need a URL to which we will make the request, right? And you need something called as a preamble, which tells, or it's like the prompt to Chat-GPT, right? Then we want to set our, obviously, our token in the header, and we want to create our header basically, right? And then we want to loop, right? And we want to, this is basically, the loop is basically the CLI tool, wherein the user is interacting with the Chat-GPT, where like I can keep asking it questions, and it'll keep sending me responses. But then you notice something like the loader, right? There was a loader that was loading there, so we need to account for that also. So that's what I'm just thinking about. Like, so the loader either can run for every single one, or it can run like for the all of the commands. So what we'll do is we'll run it for every single of the commands, no problem. So we'll keep it inside the loop. All right. So we'll have a way. So we'll have a loop, and inside the loop, a way to read user input, right? That's the most important thing, because the user is always putting some input into, like I did. I put in two, three different queries, right? And then we need the ability for the spinner to spin and wait for the response from Chat-GPT. And we also want to make the request to Chat-GPT for every single user input, right? So it also obviously, all of this is part of the loop again. And then obviously we get back some response, and we print that response. So generally these are all the things that we're doing in today's program. Okay. Now let's get started. We'll obviously need to use a couple of libraries, and in our cargo toml, what I can do is, to make our job really easy, what I can do is I can copy and paste the ones that we need here directly. So since my code is on GitHub, you can also copy and paste from the cargo.toml file. Okay, and we've used all of the libraries that we're using right now. We've already used it. So this is like the 23rd project in this playlist, and we've already worked with Serde Derive, JSON, right? Serialization, deserialization. We've already worked with Tokyo. All spinners is very, very simple. There's nothing here. Hyper is a very, very light HTTP implementation, right? It's not a full-blown like a big library, right? And then you have .env. We've already used it for loading environment variables. So you're aware about all of these things. We won't be doing a lot of stuff with Hyper, just to create, just to make that request. That's it. Like nothing big. It's not like a full-blown We're not building any APIs, we're not building like a router, nothing like that. Just one small simple request. Okay. So brought that in. We're going to use like all of the things that I just showed you. So I'm just going to copy and paste all of the things that we'll be using. Okay. Now let's start working with our structs. So for the request, firstly, I'll just have a struct for the choices. So I'll copy and paste it here, and I'll say hash derive. And at the end, we'll activate Rust Analyzer to go through all the issues and tell us if there are any issues. I don't keep it on from the beginning because it's just very distracting for me and for the viewers. So I know there are some people who say I should keep it on from the beginning, but I find it very, very distracting, and many viewers find it distracting. So please, if you want, you can keep, if you're coding along with me, please keep Rust Analyzer activated if you want to do it. But I will only activate it at the end when I'm done with the whole program. That's what I always do. Okay. Many times I don't even use it actually, but these days I use it because I like fixing bugs and errors when I run the program in the terminal, right? That's the clearest sign for me of how the program is working. But I do use, just to make it things easier for you, I do use Rust Analyzer, but at the end only. Okay. And I want to derive, deserialize, and debug. So for OpenAI, we'll have some choices like I mentioned. And inside that, you'll have text, index, log probs, and finish reason. Okay. This is a subset of the OpenAPI response. Okay, the choices. So it's going to be part of the response. That means that the response is going to have a data type or a field called choices, and this is that choices. Basically, this is what that choices reflects, right? In case you've built with me, like I said, the Golang project, you know about the choices, that as a response you get back choices and you want to print out only a part of those choices. Alright, so for the response, I'm going to have the same line, deserialize debug, and you want to say struct OpenAPI response, and like I mentioned, one of these fields will be choices, which is going to be a vector of OpenAI choices. Now, vector is a collection, so in case you're a Golang developer, you know about slices. Like slices can help you collect multiple data, like of structs, right, of a particular type. Similarly, vector also does that. Vector is a collection. So you have a struct. So one particular struct is like a template, and then you create multiple structs like this. So you'll have multiple OAI choices, and all of these, if you want to store them together, now because they're of a particular type, which is OAI choices, you want to store them with the help of a vector. So vector helps you store data of a particular type, especially which is a struct, which is the type that you've created, right? It's a collection. So choices, you have ID. Okay, so in the response you'll get an ID, you will get an object, you will get when was it created, the model that you've used, well, in case you worked with me on the Golang projects for Chat-GPT, we used the DaVinci model. So here also we'll be using that. It is I think the most expensive model in Chat-GPT, but it's also the most effective and the most accurate one. All right, makes sense. So we have the response and we have the choices. Choices basically is a collection of these choices. Then we have a request, right? The request, again, we'll copy and paste derive, but instead of deserialize, I need serialize, and with capital S. And here I'll say struct OAI request prompt. Now serialization is converting it into JSON, and deserialization is from JSON into structs. That's why we use different things. So you have to send a prompt as a request, and you send the max tokens. So I told you, by tokens, this does not mean the API token or the authentication token. This token is actually the number of words that you wanted to generate. So more than 200 is a good number usually. Now there are many more things that you can pass in the request, like the temperature, the frequency, and all of those things, but we'll just pass the tokens. That's it. Now we want to start working on our main function. Handling errors. Now we'll load the environment variable. So we'll say .env being part of this standard library only, .env, env dot okay. Okay, so there is obviously formatting issues because we're not using Rust Analyze right now, so I'll just put a tab for now. Okay, and create a HTTP connector. So I'll say let HTTPS connector new, and then we'll create a client using this HTTP connector. So to create a client, say let client builder dot build HTTPS. Okay. So the client, the requests, the body and header, all of these things you'll get from Hyper, the library that I was talking about. Okay, so that's helping you create the client for HTTPS. Now you'll also define the URL onto which we want to make the request. Okay, so the URI is copy and paste it from here. You have to do the same, copy and paste it from GitHub. So we're going to use, like I said, the DaVinci model. So you can use 001 or 003 also. Both of them will work fine. And we're using the completions API. What you're doing right now comes under text completions. The preamble that we'll pass it will be generate SQL code for the given statement. All right. Also, a huge shout out to my intern Nikhil George, who helped me build this project. Right. So I can't, I'm quite stretched everywhere, so I can't be in all the places at the same time. So whenever I'm busy, he helps me build projects. So because building all these projects and then shooting them, it's a lot of work. So I always need help in building. So a big shout out to Nikhil. If you're listening, thanks a lot. String is equal to environment variable. We'll set now the OpenAI token By the way, all of the projects that either I build or my interns build, all of that is MIT licensed, in the sense you can use it anywhere that you want. It's all for you guys, completely free. It's just our way of giving back to the community, right? So like include this in your portfolios. Try and get a job, right, by including this in your portfolios, and that'll make us really happy. That'll make me really happy if you get a job. But let me know once you get a job. Let me know. Post it on like social media or something, right? So at least I should know that something positive is happening. I'll be really happy for you. So this is OAI, not OAT. Now I'll be making some small mistakes here and there in terms of spellings and all that. Please don't mind that. We'll fix all of that at the end anyways, right? I know it can be very unnerving to for junior developers when they see small mistakes being made. Please trust me, that's how I mean, that's completely all right, right? When you trust your debugging skills and when you trust the compiler to catch all the errors for you, you become really confident and you don't really care about the mistakes that you make when you're typing or when you're coding. Okay, so we have set our header. This is our URL, so I'll just match the comments there. This was the URL that we created. We had created our preamble, and then we started working with our token header. All right, and I'll just I'll start with my loop. Okay, so for my loop, I'm going to now the next part comes where you have to read the input from the user. Okay, now, there are multiple aspects to this. The first is, when you saw the demo which I was showing you in the beginning, you saw that it gives you a prompt, like a bracket for you to type whatever you want, right? It gives a prompt then. The prompt looked something like this, like a bracket, like an angular bracket, right? So you want to print that out first. So I'll print that angular bracket there. And this is what will tell the user that he has to print, like write something in that. Now, whenever he writes something, right, he's going to write a complete sentence. When he does that, you need to be writing that to a stream, right? And you need to ensure that the stream like stores everything in a buffer. It's a temporary storage, and then it's flushed out after that. So we'll say std out dot flush dot unwrap, and we'll create a mutable variable called user text, right? This is where we'll store what the user will type. So string new, and now let's start reading. So we'll say std in and to read what the user has said, we'll say dot read line ampersand mute user text, right? User text that we just created. So you know, read into that, and we'll say expect fail to read line. If there's an issue, we'll just say fail to read line. That's our error handling. And finally, empty. Now we want to work with, we want to think about the, actually here at the end, if everything goes fine, we'll just say okay. Okay, now here we want to start thinking about the spinner. So copy and paste this text here. So for the spinner, what I'm going to say is, I'm going to say let sp is equal to spinner, because we're using the spinner package as you saw, and we'll say spinners. What type of spinner do you want? We want dots, 12 dots, and here we'll just say /t open AI is thinking ... right? So that's what it showed you when I was waiting for the response. it showed you that spinner and it said OpenAPI is thinking. Now it's time, while we've given the user something to look at, which is the spinner, in the background you're making a request with the user text that the user gave you, along with the preamble and the auth token. Okay, all of these things. So what we'll say is, we'll say let OAI request equal to, it's going to be of type OAI request, the struct that you just created earlier here. OAI request struct, right? I'm going to feed it those things only. We're going to feed it the prompt format comma preamble comma the user text comma max tokens 1000. Okay, you can tweak this, you can make it 3000, 2200, doesn't matter. More than 200 is I think good. It gives it enough leeway, gives Chat-GPT enough leeway to give you the right the long response, right? Now we're going to start working. So this is the request that we just made to Chat-GPT. All right, I'm going to start working with the response. Start thinking about the response. But still, we've created just the request object. We've not actually made the request yet because we want to send the header, right, in the request. So let's do that. So here I'll say let body equal to body from Surday JSON to underscore vec ampersand OAI request. Okay, and here you'll say let request equal to request post URL. So you have created the URL. So first you have the request, right, that you'll send in the body. You want to send this in the body of the request. Then you have the URI on which you want to make that request, right? So we have the URI. Then we'll have our header. We're going to pass our header, which will be header content type comma application slash JSON dot header for authorization comma ampersand auth header value that we created here, auth header value, passing the OAI token. Finally, the request body, and finally unwrap. Now we'll use the client that we created with the help of Hyper, the Hyper package, and we'll send that request. The client that I'm talking about is the client which we created here, HTTPS client, with the help of Hyper, right? So we said request, this complete request is what we're passing there, dot await, we'll await, and here we'll say let response equal to. Okay, that's our response. So I'll just copy and paste this here. And now we're going to say let body equal to hyper body aggregate response dot await. Right. And let JSON OAI response. So JSON from reader body dot reader spinner of stop. We have the JSON now, and we just want to print that out now. So here we'll say print ln, and finally print ln comma JSON dot choices 0 dot text. Okay. So we got the response back, put that in the body, hyperbody, got that in JSON, and JSON had choices, and then you print out the text that we got back from Chat-GPT, right? This is our entire program actually. I'll go over it again quickly. We got all these things that we'll be using. Dot environment for dot environment. We'll be using hyper. We'll be getting the body, client, request, and header. And then create the HTTP connector with this. We need SERDE for serialization and deserialization. We need the spinner. We need the standard environment and IO for reading the input from the user. We created 3 structs for our choices, our response, and our request. And that's how we made the request with prompt and max tokens. And when we got back the response, we had choices, and we print out a particular part like the choices.text. Right? In the end, when you see choices.text, that's what we printed out, choices.text. Okay. So you have your Tokyo main to be able to use async main, and you send back a result obviously. Use dot environment to load the environment variables, create a HTTP connector, create a client with the help of the HTTP connector using the hyper library, create a URL, a preamble, and your tokens in the header. Go through the loop, and you print out a prompt asking the user what he wants, right? And then you create a mutable text called user text. It's a new string. Then you start reading and bringing that into user text. If there's a problem, you'll say fail to read line. Create a spinner, create a request, OAI request format with this format, and maximum tokens 1000. Body. The body that you want to pass is the complete request, right? Then you make the request. You make the request with this package and the post request to that URL that we just created. Pass the header with authorization and application JSON and the body. You get back a response by using the client to make that request. And the body you get back, you use it with hyper, and then you get the JSON from there using OAI response struct that you created and using SERDE JSON. You make the spinner stop, and you print out json.choices.text. And now we'll switch on our Rust analyzer. And it will ask me, I think, to restart the VS Code. I think I've enabled it, right? Usually it doesn't ask me to restart, but it's not showing me anything new. Maybe I have to wait, or maybe I'll just restart it anyways. So I'll say again code yeah, it's performing its checks, and it's given me some errors. Okay, so it's started showing the data, and now it's showing me that 2 small errors here. So the first error is here because obviously there's no exclamation mark, so that should go away. And there is one more issue somewhere, and I can't find. Yeah, so here it's saying in my async there is issue for send, because send needs to be capital. And rest of the things are not really errors. It's just saying that we have not used these things, which is okay, because we could use it if we wanted to. And you would need to use all of these things if you change the examples a bit. I'm using this particular example for SQL code, so I don't need those in this particular example. So now what we can do is we can say cargo. Oh yeah, it won't work because I've not yet put my env key. So I'll do that, and then we'll run the program together. So now I've put my API key there. Make sure you don't by mistake commit your key to GitHub. Somebody else could end up using your key and end up draining all the money in your card. So just be very, very careful about that. Make sure you use a git ignore. Can keep changing the keys, like keep deleting the old keys if possible, at least for Chat-GPT, because it's usage based, right? So that's a bit of a problem. So here what you'll say is you'll say cargo run, and we'll build the entire package for you. And it did give you some warnings. Another program is running. So here we'll say create a table with columns, name, age, gender. But I should also give it variable students with columns, name, age, gender. Right, so the format looks a little off. Okay, let's say select all records from employee page. Okay, sometimes you'll get a little unformatted response, but this also could be that there's something wrong in the program. So what I'll do is, before committing it, I'll just check if there's any issue. But sometimes you'll also find that OpenAI gives you different response, because here it looks completely all right. Select start from employee. Sometimes it gives you a little different responses. I'll still check it before committing. But this is the end of the program, end of the video. Thanks a lot, guys, for watching. I hope you've learned a lot in this video, in this project. And I'll keep putting out awesome content like this, where we'll keep building awesome stuff. So do share it with friends. Do subscribe in case you haven't subscribed to this channel. Do consider joining this channel if you want. And share it with your friends. Make sure everybody subscribes. Everybody knows that, you know, you could build awesome stuff on this, like if you subscribe to this channel. And thank you for watching, and I'll see you in the next video.